Hold on to your seats. This is your lucky day because you are going to learn how to read a food label. And for your enjoyment, it is going to involve math. Yeah, I know you're pumped now. So anyway, but before we get started, I know you enjoyed those Oregon towns so much last time that we are going to give her another shot here. So let's look at number 5. What town do you think that is? I'm only going to give you 5 seconds. 4, 3, 2, 1. Tigard. Yeah, there's a tie with a guard there. Number 6. Okay, it's kind of south of Portland. Roseburg. All right, this 7 might be a toughie. That little wiggly thing up there at the top it's kind of like a snake. So what do you think? You may not even know where this is, but Kokio. So Coke with an eel. Number 8 should be easy. It's Eastern Oregon or Central. It's kind of Central Oregon, but it's Bend. How about 13? Think you get that one? So it's Gearhart. 14. I'm not even sure I know where this is, but guess I could look it up. But that is a scale right there. That lady, I guess. I don't know. I got some slippers like that, and I think I've seen some slippers on stuff. They don't have bunny heads like you guys have on yours. Halfway. And the little inscription, if you can't read it, said, "This belongs to Joe." And so Eastern Oregon, where you guys never go. You ought to go there. It's a nice place. Joseph. It's beautiful over there. And then 16. Yeah, I don't know if they still play that game or not. You may not even know what those are. But Jacksonville is that one. Man. I'm not only teaching nutrition, but we're teaching you some Oregon geography through pictures. Okay. All right, so let's talk about food labels. Food labels, this is a standard food label, which basically means that most typical foods, and I'm going to show you some exceptions in a second, most typical foods, this is the required information that's on a food label. And it's in the required format. Basically, it states that every single food label, nutrition facts label has to be in this format, meaning that at the very top you've got the size, you got the servings per container, calories from fat, and then these are in the exact order, and they have to be in that order for every food label. The reason for that is, if everybody put information wherever they wanted to, the consumer would never know where to look. So this way, if it has a specific standard format, then you should always know where to look to find what you need to find. So this is the standard food label that everyone needs to have, that has a standard food that's not an exception. There are some, and let me show you some here. Tuna. They tried to get tuna to go with the standard label, but the manufacturers of tuna basically argued that their container has a standard of identity, basically meaning that squatty little can was what people expected tuna to come in, and they couldn't get all that information onto the can and be in the font that is required, because on most food labels they require a specific font at least so that people can actually read it, so it's not so small that you can't even see it. So this is what is required on a tuna can or any other can that may have a standard of identity that would be the lettering would be too small if they tried to get everything on there. to do that. And then any type of food, if you call it food, that has nothing in it, then it should. There's no reason for a soda to have the information about cholesterol and all the different kinds of fats and all those kinds of things. There's no reason for them to be there because there's nothing there. So it would be just a bunch of zeros. So they're allowing soda, or basically, let's just say anything that has no nutrients whatsoever, just to show the calorie nutrients that would give you to the calorie amount. And then if anything else is in there that would be significant that is on the label, like sugars and sodium, then they'd have to put that on there. So there are exceptions, but the standard food label is the one that you will see on most products. So the nutrients that are on a standard food label are declared based on the daily value. And we'll talk about where they come from, but when you look at a food label, these percentages are daily values that come from two standard sets of guidelines that have been put together. So we'll go over those in a minute. And then in the bottom you have the vitamins and minerals that are designated there. But again, this is a standard food label. You might see on other food products more information than what's on this label, and that is by choice. They don't have to. They do it by choice. A lot of it, you might not be surprised that it's a marketing tool. Now, if you do say you have added nutrients, you have to put those on the food label. And so if you make some kind of a claim about having higher vitamin C or something like that, then that has to be on the label. Or if you have high zinc, then that would have to be on the label as you declared that. But there are some food products that put a whole list of different nutrients on there. And a lot of times it's marketing to get people to buy it, because they'll compare two products, and if one has a deeper label or more information on the label, they'll think that this one product doesn't have those in there, but this other one does. But that's not true. It's just that one decided just to follow the standard food label, and the other one decided to expand that. But it does get people to buy their product, so it does work. But anyway, so let's look at the daily values and see where they come from. And that'll give you some more information about the food label. So the daily values are reference values that are put together by the FDA, and they're specifically made for the nutrition facts label. You won't find daily values anywhere else besides on food labels, because that's the standard. And they are comprised of two different guidelines. And as we go through, what I need you to understand is that the information on the food label is not meant for someone to design food intake values from. It's not meant to design a diet that you get 100% of everything on these food labels, because they're meant for populations. They're not meant for individuals. They're meant for specific concerns that you might have, so that you know if you're buying high or low or something. So as we go through, I need you to understand that these are not meant for individuals to meet 100% of necessarily. So let's look at the RDIs and the DRVs and look at where they come from. The RDIs are reference daily intakes. By the way, you'll need to know these acronyms, RDIs, on the exam. So you'll need to know where they come from and what they are used for. So just try to list those down, do some flip cards or something, because it's not hard to mix up RDI and DRI. I mean, they're very similar. So you kind of have to get those differentiated as we go through. But the reference daily intakes come from the 1968 RDAs. So that's, again, one point to be made that it's not meant for individuals to meet, because the latest RDAs, or basically they're part of the DRIs, have different values than they did in 1968, but the food labels are based on 1968. So they are not meant for individuals to set their diet with. And they're also the highest values of the nutrients that are on the label. And so, for example, if you look at iron, you'll notice that it's the female is for 18, and that's the highest level, because it's during childbearing years, the female would be 18, males are 10, but they set the value at 18. So why did they do that? Well, they did that because they don't know who's going to eat the food, number one, and so anybody could eat the food, and the idea would be you would be getting enough, kind of thing. And so the standard is based on the highest value, which means it would be too much for males. So again, if you're a male, you wouldn't want to follow the percent DV on there for iron, because actually it doesn't have a percent DV, but anyway, you wouldn't want to follow that. And calcium is 1,000. I mean, it's pretty good, but now, it's 1,200 really is a standard. And then I'm not sure where 60 came from, but, and then vitamin A is a little bit different for males and females, and they set it at 1,000. So anyway, it's just a standard that the FDA said, basically, okay, these are going to be the standard, and they had some criteria for that, but it's not meant for everybody to meet those. And then the daily reference values, basically these don't have RDAs. They don't really have standards. These were standards that were made by the FDA just because nutrition surveys that were done, that we talked about previously, showed that these were nutrients that should be of health concern for consumers. So they said, hey, we need to put these on a food label so that consumers can look at them and they know what they're getting in these foods, of these nutrients that may have some health issues related to them. So again, you can see, by looking at them, that what you've heard, I mean, we haven't even talked about them yet, really, but you've heard about them, that we should lower saturated fat, we should lower cholesterol, lower sodium, increase fiber, that. So it's something that most consumers have heard enough about that if they wanted to, they could look on the label and they could determine if something was low or high fat, kind of a thing. So these nutrients don't really have an RDA, so you wouldn't find them on a chart like you would some of the other vitamins and minerals and things like that. But the FDA said these are important enough health issues that we need to inform the consumer about those. So those are the two guidelines that basically make up the DVs. Now the serving sizes you see on food labels are basically supposed to be something that is familiar with consumers. So, and you'll see both of these values. You'll see mils and cups and things and so they have to be something that's normal. Now a slice of bread is different. A slice of bread can be different values, and so you need to be careful with that, because you can have a product that says, ooh, we've reduced our calories, but they didn't change the formula of the bread. All they did was make the slices a little thinner, because all the information on the food label is based on serving size. So if you change your serving size, you can make your product look like it has less calories than it actually does, or less fat, or whatever you want, if you change the serving size, because the producer of the food product can make as long as it's a standard measure, they can make their serving size whatever they want, and then they would then have to adjust their nutrition facts to fit that serving size. So you have to be careful because there will be advertising is less calories per serving. And people will think, well, they reduced the amount of calories in the food. No, they actually made it a different serving size. So be careful on that. Some other things you need to know, just kind of consumer awareness things, is that we don't want to get 100% of everything on the food label. As you can see listed here, these would be things that we want to be less than 100% DV on. And that's what it's meant for. It's meant that if you have a problem with heart disease, say, that you would go and you would compare products and look at things and say, well, which one is lower in saturated fat because my doctor said I needed to reduce that, or cholesterol or sodium or reducing sugar. You would want to know which one has the lowest sugar because you want to keep those below 100% per day. But these you would want to get at least 100% or more per day in the food that you eat. So that would be one comparison tool. The other thing about the food label is that every one of the DV values is based on 2,000 calories. So again, another reason it doesn't fit everyone, because 2,000 is kind of in between males and females. So females 1,500 to 2,000, males 2,000 to 2,500 is fairly normal. So a 2,000 calorie kind of goes in between, but that just means that if you're at 2,500, the DVs don't fit you. If you're at 1,500, the DVs don't fit you. Because they're based on the 2,000 calorie diet. But that's the DVs. The vitamins and minerals here are based on the DRI. And the other ones are based on the RDI kind of thing. So what you need to again do is you look at those at 2,000 calories, and then you have to make an adjustment there to make it fit what you eat. But you can see where these come from. These come from the DRVs. I was kind of screwy there. The DRVs, and these from the DRIs that we just talked about on the food label. Some quick guides that you'd want to look at is when you're looking at the DVs, what you'd want to look at is anything that is right around 5% would be considered to be low. So it can go either direction. If you're looking to reduce your saturated fat, then you'd want to look for a product that was close to 5%. Excuse me once again. But if you wanted to increase your fiber, you would want to pick something that's greater than 5%. You'd want to pick the 20% value. And then again, looking at food products, if you saw saturated fat was 20%, then what you'd want to do is not choose it. You'd want to try to find a product that was similar, that would be closer to that 5% goal as opposed to the 20% goal. So those are the quick guidelines that you do as you're looking at your food label. Look at the percentages, look at the 5%, 20% rule, and choose accordingly whether you want to raise, get it higher, or if you want to lower it. So the food labels are actually meant as a comparison tool. They're not meant to base a diet on, where you actually look at two similar products and you look at the percentages using the 20%, 5% rule, and you choose the one that best fits you. If you need to reduce your sodium, you look at the sodium and use the 5%, 20% rule. If you need to reduce your saturated fat, same reason. If you wanted to increase your fiber, use the 5%, 20% rule on that. So it just depends on if you want to increase or decrease things, whether, where you want the percentages to be. But it's used, they're meant to compare things. They're not meant to base a diet on. So let's I want to go through and look at how we can calculate these things, and you will be expected to calculate these on an exam, where we would put a food label on there, blank out some numbers, and you'd be able to figure it out. So let's go through and look at how we can do that. So here's a standard food label, and the first question is, where do they get these calories from? Where did they get 260 calories there? Well, the basic assumption you'd think is, well, they're coming from the caloric nutrients, so the nutrients that have calories in them, or what we called earlier the energy nutrients. And if you remember, the energy nutrients were protein, they were carbohydrates, and they were the fat or lipids. If you also remember, as we went through, or when you read your book, you know that fat is 9 calories per gram, and you see it's 13 grams, and carbohydrates are 4, and proteins are 5. And so to determine total calories, or where they got 260, you would take 13 times 9, you'd take 31 times 4, and you'd take 5 times 4, and you'd add those up. You actually come up with 261, but they rounded down to do that. Now, when you get an exam and you're saying, well, I can't remember those numbers, well, actually, if you look at the bottom of the label, you can see they're there, right there, for you to find. So on your exam, we're going to give you all this information. We just expect you to know where to look and how to use it. So to get the total calories, you would just do your multiplication. I told you we were doing math. So on your first exam, you'd want to bring a calculator or have a calculator with you when you do that. But you just multiply and add them up, and it should give you pretty close to the calorie amounts. Okay. Now, the other question is, where did they get the calories from fat? Well, it's pretty simple. You get the calories from fat by taking 13 times 9 to get 117. And so this number here is actually the same as this number here, but they, in this case, round it up. As far as I understand, you can't round down because you can't say you have less fat than you have, but you can say that you have more if you want to. So they kind of rounded it up just to make it an even number. Maybe gives them some wiggle room also, kind of a thing. So that's how you'd find that. Now the next question would be, because if you remember when we were looking at the Senate, the guidelines of 1977, we said we would, in a daily amount, we wanted 30% calories from fat. Well, I mean, you can, eat a high-fat meal, and I guess if you dilute it with carrots and celery and stuff like that doesn't have any fat at all, you could dilute it down. The old saying, dilution is a solution to pollution. So you could dilute your high-fat foods with low-calorie, low-fat food, vegetables and stuff, and even it out. But the concern would be if you were buying pre-prepared foods and that's what you eat. So what you want to look at, though, because they don't tell you on the label, is if that's going to be your meal for the day, and if you eat those several times a day or several times a week, it would be important to know what is the percentage of fat I'm getting in these pre-prepared meals. So you can figure that out by basically taking the calories and divide it into the calories from fat, and you find out that this product here is 45% fat. Okay. Now, what importance is that? Well, number one, it's pretty high fat. It's almost 50% fat. It's almost half fat. But what you want to be careful of is advertising. I mean, they're very smart people, because they can say, ooh, only 260 calories in this meal. So you buy this pre-prepared meal, you're only getting 260 calories. The problem is there's half fat. Why would you want to eat a meal that's half fat if it's low calorie? Yeah, it's low calorie, but it's not very healthy, really. And so our goal is to get something healthy and low calorie. for that. So this is a way that you can figure out your percent calories from fat, is just to do this calculation, and help you make a better choice. Okay. Now, where do they get the percent daily values? If you remember, we said the daily values were based on a 2,000 calorie diet. So the question is, okay, where did they get this 28% for sodium? Where did it come from? Well, basically we said, it's going to be based on a 2,000 calorie diet. So what we do is go down into this category here, look, and this is for all the daily value numbers, not for the vitamin mineral numbers here. But you go down and you say, okay, what they say is 2,400 milligrams is a daily value serving amount, and we want to get less than that. But so we notice we have 660 milligrams. So basically, how you would determine that is you would take 660 here, divide it by 2,400, and that would get you pretty close to 28%. So what you could expect on an exam would be that maybe we would white this 28% out and just have these two numbers, and you would have to be able to figure out what is the percentage here. Or we could go the other direction and we could white this number out here and expect you to know that to get this number you would multiply 2,400 times 28%, and that would give you 660. So you're going to need to do a little bit of math. Now, how did they find the iron at 4%? Well, again, that's going to be based on those figures from the 1968 values. And so if you remember, it was 18 milligrams was, the highest level for the woman. So if we took 4%, which is 0.04 times 18 milligrams, it'd be 0.72 milligrams of iron would be in this product. Not very high. So it's the highest RDA for iron. And again, what I show you, I just brought this back for the daily RDIs. It said that the daily value was 18. So anyway, that's not a very good. If you use the 20% 5% rule, you should be able to figure out that this is not a very good product, because both of the fat and the saturated fat are over the 20% or over, so that's considered very high. The sodium is over 20%. The fiber, there's no fiber whatsoever for that rule there. This is 4%, so, and calcium is not very high, so there's really no nutritional value within this product whatsoever. It's low in calories, but it's not a very good product. Okay, so sorry, let me go back. So let me go back here. I kind of ended it a little bit early. I went too far on my PowerPoints, but so what the expectation would be is that given a food label on an exam, you would be able, if we whited out some of these numbers, we could white out total calories, we could white out calories from fat, white out daily values. Probably wouldn't, unless we gave you this 18 number, we probably wouldn't expect you to figure out these, but because this information is on the label, we would probably expect you, or I know we will, to figure out either these numbers or the milligram numbers here, or the gram numbers, for a food label. And then also, if we gave you two labels to compare, you would be able to, number one, determine which one was was the best in nutrition using the 5% 20% rule, but also there's nothing saying we couldn't expect you to know which one is more energy dense. Because if you remember, energy density is looking at calories per weight. Well, you've got the calories, you've got the weight in grams, and so if you looked at two labels, you could determine which one is the most energy dense. If we ask you which one was more nutrient dense, nutrients per calorie, I mean, you have the calories, and you could make up some information. I mean, there's really no rule that says how to figure out nutrients here, but you've got the nutrients down here, you've got fiber and protein, and then you've got these nutrients, which, you wouldn't necessarily think, you wouldn't want to be part of a nutrient-dense food. So it's pretty limited to the fiber and the vitamins and stuff as to which one would be nutrient dense. But some individuals look at nutrient density, look at the word, and they see, and they just look at the two labels, which one has the highest calories, and they say, ooh, that's got to be the less nutrient dense because it has the most calories. But it's nutrients per calorie. So the product could have more calories, but if it has more nutrients and you do some division, I mean, you could do a comparison between the percentages of vitamins and minerals to calories, and make some comparison there, and determine that the higher calorie food product is actually the more nutrient dense. Okay, so be prepared for that on your exam, and then also, hopefully this has helped you, that when you go to the store, especially if, nobody expects anybody to read the whole food label and do all that, but if you do need to lower sodium, then you could look at the percentage for sodium. If you need to lower fat, you could look at the percentage, use the 5% 20% rule, use that rule for the fiber, and then, so you could do a quick look at two products to make sure that you're buying the best one. Okay, so hopefully that helped you and make you a better consumer. And then I think next time we'll actually be getting into the nutrients and then start looking at some of the nutritional concerns that we have. But hopefully in the last few lectures we have made you a better consumer.